Hi everybody. This video is an introduction to the concept of a relationship between numbers and the concept of what is referred to as a function. So what we're going to be concerned with in algebra is the concept of a function. But to get there, we need to talk about relationships, okay? So let's consider the following example. Very simple, we're all familiar with. A car is known to have a gas mileage of 25 miles per gallon. This implicitly defines a relationship between the amount of gas in the tank and the number of miles the car can be driven. So now we have a relationship between two sets of numbers. One number associated with the gas, amount of gas, the second number associated with the number of miles that can be driven. So let's assume the tank holds up to 10 gallons of gas. In this case, we have the following relationship between the number of gallons, and we're going to just work with whole numbers here because you could have a half gallon, 3/4 of a gallon, 2.4 gallons, whatever. Just work with whole numbers here. And the number of miles the car can be driven. So if the tank is empty, we're not getting anywhere. If we have 1 gallon of gas, we're going to go 25 miles because the miles per gallon, and we're going to assume that's precise, okay? We don't want to get picky here. If I have 2 gallons in the tank, well, that's going to get me 50 miles, 3, 75, and then finally, if we keep going, 10, 250 miles. So here are, let's say, one set of numbers, and here is a second set of numbers. And we have a relationship between the two sets. We can look at the number of gallons we put in the tank as input. This is important. We're putting the gas in the tank. This is also called the domain in math terms. We can also look at the number of miles traveled as output. We control the input. We control how many gallons we put in the car. What we don't control is how far we can go, right? Because that's based upon the miles per gallon. This is also, output is associated with the word range in math terms. So here's my domain numbers, and here are my range numbers. Just getting you ready for the future here. All right, so let's move on. So that's really a simple example of a relationship. So we're going to continue with that concept, that particular problem, to get another idea across to you here. A variable is simply a letter that represents a number. So typically we do work with X, Y, and Z, but any number could actually be used. So for our example we're going through, we might let X represent the number of gallons we put in the tank when we pull into the gas station. We might let Y be the number of miles we can travel. So in our relationship from the previous page, the number of gallons is associated with X, the number of miles is associated with Y. Our relationship tends to be a relationship between numbers. One way we actually do this is by what we call ordered pairs of numbers. The first number is associated with X, our domain. The second number, Y, our range, and we put it in between two sets of parentheses. So in the context of this problem here, 5, 125 means I'm talking about 5 gallons of gas and getting 125 miles. So below here, you will see the ordered pairs associated with this relationship. Okay, so typically, well, not really typically, but to get things rolling here, relationships really do consist of ordered pairs of numbers. And here they are. Let's get moving. Now, in algebra, we really don't work with ordered pairs. They're going to be there. You're going to see that. But when we talk about a relationship, we're going to really work with what we like to call a function. And a function really is, well, when we get going, is going to be expressed in terms of an expression and not a bunch of ordered pairs. Even though the ordered pairs are there, they're implicitly there, meaning you'll see what I mean. A function is a relation between two sets of numbers. So a bunch of ordered pairs. One set is referred to as the domain, the independent variable x. I like to say input, domain, input. Domain is what you control. You input, you decide what drink you want. That's the domain. The range, the second set of numbers. The dependent variable y is what you end up getting. You walk up to the Coke machine, you press Coke. The output, well, we hope it's Coke. It might not come out Coke, it could come out Pepsi, right? Well, that's another story for another day. In the end, input domain, output range. What do you control? You control the button on the Coke machine. You control how many gallons you put in your gas tank. Now, a function requires that any given domain value, there's one and only one range value. That's what a function is. So if you look at if you look at all the possible x's, x does not repeat. Here's something that's not a function. I just said it. You press the Coke button. You get a Coke. You press the same Coke button. You get a Pepsi. What's happening is the Coke button is giving you two different outputs. Coke, Pepsi. Just not your day if you didn't want Pepsi. Well, that would not be functioning. That's the same idea that's going here. In other words, you can if you press button 1, you always better get 5 for your answer. You can't get 5 for your answer and maybe -8 another time. It will always give the same result. Same input, same result. That's what a function is. Anytime same input and something else can happen, that is not a function. Functions are collections of ordered pairs. So for example, just reminding you, as an ordered pair, this is telling me x is 3 and y is 4. But this ordered pair is telling me x is 4 and y is 3. So they're different. Order plays a role. We have a domain, the input, we have the range, the output. Okay? So if I gave you a function, you could not see this as a set of ordered pairs for that function. And the reason why is, what this is saying here, if I give you an x, there can only be one y value. You can't have the same x going in different directions. No, not a function. But you've been to a Coke machine where you had 4 buttons that said Coke, and you got Coke, right? Doesn't matter about different x's going to the same y. The same x cannot go to different y's. So you're going to be looking at, well, we'll see. But here we go, moving on. So here is a collection of ordered pairs. Don't worry about the curly braces. That's typically what you're going to see them in. But there's a pair of numbers, pair of numbers, pair of numbers. And this is an example of a function. So what I'm going to do is simply check one thing. If it's a function, my x values have to be different. My x values have to be different. They are. My domain are my x values. My range are my y values. For a function, your x values have to be the same. Okay? So that's why it's a function. I really didn't expect you to write anything down here. But I can't have the same input giving me different output. Think about a well-functioning drink or, vending machine. This collection of ordered pairs is not a function. Here's why. If you notice x is 3, x can go to 3, but for this one here, x goes to 5. Functions require same input, same output. That's not the case. That's why it's not a function. Now the domain, you could still be asked for. It's just simply your x values. Your range is your y values. Okay, so you should be saying it. Domain, x values, range, y values. Is it a function? X's have to be different. Nope. X's have to be different. Yes. Now in this course, we're going to focus on functions not as a bunch of ordered pairs, which they are, but we're going to be thinking in terms of really an expression, in a way, an equation. I kind of was iffy about what word I should put here, but it's not going to affect you. Okay. But later on, you're going to see what I mean by that. So here's a couple examples of a function. Okay. We're going to be showing something later about the y. I just wanted to put the y here because, again, we identify x as the input and y as the output. So let me give you an example of this, and then you can do all of them. In this ordered pair here, I'm telling you x is equal to 0. Well, if x is equal to 0, y has to be 5. Plug in x equal to 4. If x is equal to 4, y has to be 13. So that's basically what you do. That's how you get your ordered pair. You see, you're going to be given functions in this form here. You really don't work with functions as ordered pairs, which they are. I just showed you. Here's the relationship. Here's the associated ordered pairs. There's a lot more of them. I could put 100 here. 200 plus 5. Another ordered pair in the relationship is right there. Another example. These are some ordered pairs associated with this relationship. I'm relating y to x in terms of an expression, a equation here. Notice if you're plugging in -1, you get 0 for your output y. Well, this is it. I hope you enjoyed this video. Let's just make sure it comes to a conclusion. Bye.